Welcome to the virtual facilities tour of the Coastal and Global Scale Nodes portion of the Ocean Observatory Initiatives program. The tour agenda will include an overview of CGSN scope and responsibilities, WHOI dedicated facilities, as well as support facilities provided by Woods Hole Oceanographic Institution. CGSN operates and manages 3 moored arrays for the Ocean Observatory Initiative: the Coastal Pioneer Array, the Global Irminger Array, and the Global Papa Array. Responsibilities include refurbishment and upgrades for electrical, mechanical, and instrumentation systems, integration and testing of all mooring components, deployment and recovery cruises, as well as data management. CGSN also supports electrical and mechanical refurbishment activities for the Endurance Array. The Coastal Pioneer Array is located 75 nautical miles off the coast of Massachusetts in water depths ranging from 90 to 455 meters. The Coastal Pioneer Array infrastructure includes 3 coastal surface moorings. These coastal surface moorings carry the power, controls, data management, and telemetry systems to support scientific instrumentation that is located at the surface mounted on the buoy itself, in a near-surface instrument frame just below the buoy, and at the seabed mounted within the multifunction node. There are also 5 coastal profiler moorings deployed during the summer months, and an additional 2 coastal profiler moorings deployed during the winter months. The coastal profiler moorings carry a wire-following profiling vehicle which provide water column profiles and instrumentation measurements. The buoy itself carries telemetry systems. There are also 5 coastal patrolling gliders, which follow predetermined tracks along shelf and across shelf, and 2 coastal profiling gliders. All systems, the coastal surface moorings, the coastal profiler moorings, the patrolling gliders, and the profiling gliders, all provide real-time data through their individual telemetry systems back to the WHOI data portal. The infrastructure is turned, recovered, and deployed every 6 months, and AUV survey missions are performed every 2 months. The Global Irminger Array is located 120 nautical miles off the coast of Greenland and is deployed at an approximate water depth of 2,800 meters. The infrastructure located at the Global Irminger Array includes 1 global surface mooring. Similar to the coastal surface mooring, the global surface mooring provides the power, controls, data management, and telemetry systems required to support the scientific instrumentation. Scientific instrumentation is mounted on the buoy itself and just below the surface within a near-surface instrument frame, as well as at fixed points along the riser between the near-surface instrument frame and the seabed. There is a hybrid profiler mooring located coincidentally with the surface mooring. The hybrid profiler mooring includes a wire-following profiling vehicle to provide full water column scientific measurements. There are 2 flanking moorings. These moorings are subsurface moorings and carry instrumentation at fixed points along their risers between the subsurface flotation and the seabed. There are 2 global open ocean gliders, which will transit and sample between each mooring, as well as a global profiling glider located in the vicinity of the surface mooring and the hybrid profiler mooring. The global surface mooring will real-time telemeter data back to the WHOI data portal, while the open ocean gliders will act as data mules collecting data from the hybrid profiler mooring as well as the flanking moorings and transmit that data at each surfacing. The infrastructure is turned or recovered and deployed every 12 months. The Global Papa Array is located 500 nautical miles off the coast of Alaska in a water depth of approximately 4,250 meters. The infrastructure at the Global Papa Array includes 1 hybrid profiler mooring. This hybrid profiler mooring is somewhat different than the mooring at the Irminger Array in that it carries 2 wire-following profiling vehicles to be able to sample the full water column at the Papa site. There are 2 flanking moorings. These are subsurface moorings, each carrying instrumentation at fixed locations along the riser between the flotation and the seabed. There are 2 open ocean gliders, each transiting and sampling between each of the mooring sites, as well as a global profiling glider located in the vicinity of the hybrid profiler mooring. Data telemetry is solely performed by the open ocean gliders at the global Papa site. The open ocean gliders act as data mules, collecting the data from the hybrid profiler mooring, as well as the flanking moorings, and then at each servicing transmit that data back to the WHOI data portal. The infrastructure at this site is turned or recovered and deployed every 12 months. The next part of the tour will discuss WHOI dedicated facilities and associated activities. There are 3 primary facilities located on the Quissit campus of Woods Hole Oceanographic Institution. The first is LOSOS, which is the Laboratory for Ocean Sensors and Observing Systems, LOSOS North, a smaller support facility for LOSOS, as well as the Coastal Research Laboratory, which is the home of the Mooring Operations and Engineering Group that support all deployment and recoveries of CGSN hardware. LOSOS is a modern 26,000 square foot facility dedicated to ocean observing systems. 80% of the facility is in use by CGSN. The facility is split into 2 floors. On the top floor is project management, operations, the electrical lab, and the instrument lab. The LOSOS bottom floor houses the mechanical lab, profiler mooring lab, the vehicle lab, as well as the general use high bay. The LOSOS project management spaces include conference rooms, offices, cubes, as well as office space for the WHOI project management office. CGSN has a dedicated room for infrastructure operations and management. This could include glider piloting upon initial deployment, monitoring of gliders once operating autonomously, assessing infrastructure and instrumentation health as well as data quality, and actively managing mooring power systems, control systems, and telemetry systems. We can also view and monitor ROV operations at the Pioneer Array and provide feedback to the science team in real time. And we can also monitor weather and vessel activity in the vicinity of all the arrays. The Electronics Lab, or Elab, is responsible for all refurbishment design and upgrades for mooring systems. These include power systems such as solar panels, wind turbines, batteries, and power distribution, data distribution and storage, mooring control systems, and the satellite telemetry systems such as Fleet Broadband and Iridium. The Elab is set up with dedicated tooling specific to the inspection, repair, replacement, and refurbishment of all connectors, bulkheads, cabling, boards, and subsystems, as well as the pressure housings required for all of the electronic systems within our moorings. Since the Elab is also responsible for design and upgrades of new systems for the moorings, the Elab maintains an electronic test bed that can mimic all mooring systems and allows the troubleshooting of existing systems as well as the testing of new components, including testing of new instrumentation and software and firmware upgrades. There is also a rooftop test bed that allows the Elab to test existing and new power subsystems such as solar panels and wind turbines. The Instrument Lab manages all instrumentation for the CGSN program. Following mooring recovery and teardown, the Instrument Lab will inspect and prep instrumentation for vendor refurbishment. The instruments are then delivered to each vendor, where the vendor performs its own inspections, replacements of components, calibration, and quality testing. The instruments are then returned to CGSN, where the Instrument Lab performs a quality conformance test on all incoming instruments. The instrument lab is also responsible for research into and testing of new instrumentation as part of the tech refresh process. Various test fixtures and a dedicated saltwater test tank are available to the instrument lab for troubleshooting and to support quality control measures. The instrument lab is also developing additional tooling to support in-house calibrations of scientific instrumentation. An example of that development is the upcoming ability to perform dissolved oxygen 2-point calibrations in-house. All of the processes and tooling developed by the instrument lab will also support the tech refresh process in the upcoming years. There are approximately 1,500 instruments in the CGSN inventory, and approximately 800 instruments will go through the instrument lab process every year. The mechanical lab contains all the tooling required to support the teardown, build, and integration of the 8 surface moorings of the CGSN program. Included in the mechanical lab is a light fabrication shop with tooling such as drill presses, band saws, grinding, and sanding machinery. All of this tooling supports the maintenance and repair of mechanical components such as the universal joints, flanges, buoy wells, and towers, as well as the fabrication of minor pieces such as instrument bracketry and other small components used in the integration of the moorings. For large-scale fabrications or repairs, the mechanical lab will work directly with a series of qualified vendors or directly with the WHOI fabrication shops. The Profiler Mooring Lab is responsible for all wire-following profiling vehicles, as well as the coastal surface profiler moorings. Following recovery, the Profiler Mooring Lab will disassemble all moorings, continue with the refurbishment of all mooring components while the vehicles are returned to the vendor for refurbishment. When the vehicles are returned from the vendor, the Profiler Mooring Lab will put the vehicles through a quality conformance testing program. The Profiler Mooring Lab has developed several tools, including calibration test tables, to verify the quality of the vendor work. Once all the vehicles have passed quality conformance testing and all the mooring components have completed refurbishment, the Profiler Mooring Laboratory will commence reintegration. Reintegration is the assembly of the complete mooring system. This includes the towers and flotation, the telemetry and power systems, the data management and controllers, the riser components, and the vehicle itself. Once burn-in is complete, the Profiler Mooring Lab will prepare all moorings for shipping or directly for deployment, depending on the port of mobilization. The Vehicle Laboratory is responsible for all gliders associated with the CGSN program. There are 26 coastal and global gliders in the CGS inventory currently managed by the Vehicle Lab. Following vehicle recovery, the Vehicle Lab will inspect and categorize all refurbishment work needed to be done on each vehicle. Depending on the categorization of the work, the Vehicle Lab may perform simple maintenance and refurbishment in-house to quickly return a vehicle back to service, or may ship full vehicles, bays, or instrumentation back to the vendor to support more complicated refurbishment activities. Following the return of the vehicles, the bays, or the instrumentation, the Vehicle Lab will place all components through a rigorous quality control inspection and test program. This includes placing the vehicle in a dedicated test bed to verify the vehicle operational systems. The Vehicle Lab will then assemble the vehicles required for the next mission. The Vehicle Lab includes a test tank where the vehicles will be ballasted for their specific deployment location. This test tank can also be used for troubleshooting prior to deployment. Dependent on vessel and vehicle availability, a test deployment may be performed at the Pioneer Array prior to primary deployment. With its bay door access, high ceilings, large work area, and 10-ton gantry crane, the high bay is specifically designed for the assembly and disassembly of the large coastal and global surface moorings as well as the coastal profiler moorings. The large interior space allows the various teams from the mechanical lab, electrical lab, and instrument lab to work efficiently at integrating and deintegrating the moorings and equipment in a timely manner, safe from the elements. All systems are disassembled and removed from the mooring. This includes removing all instrumentation from the buoy, the near-surface instrument frame, and the multifunction node if applicable. Power systems are disassembled, including removing the wind turbines and the solar panels, as well as the batteries from the well. All cables are then removed. Once disassembly is complete, all materials are distributed to each of the labs responsible: mechanical lab, electrical lab, or the instrument lab. Once the components have completed the refurbishment process, they are returned to the high bay for integration. The integration team will then reassemble the moorings, near-surface instrument frames, and multifunction nodes and prepare them for burn-in testing. In total, 20 moorings, a mix of surface and profiler moorings, will go through the high bay disassembly, assembly, integration, and prep for burn-in process every year. Following integration in the high bay, the surface mooring components are moved to the yard. The surface moorings are connected to their riser components, such as electro-mechanical cables, chains, and stretch hoses, as well as the near-surface instrument frame and the instrumentation from the multifunction node if applicable. The near-surface instrument frames, as well as the instrumentation from the multifunction node, are placed within the 3 test tanks located at the back of the yard. Once all components are integrated and within the tanks, burn-in testing begins for each of the surface moorings. Burn-in testing continues for several weeks, with the data being generated monitored by the integration team. Once burn-in is complete, the moorings are prepared for shipping or deployment, depending on the port of mobilization. The yard also provides a large area for staging of international and domestic shipments, as well as short-term and long-term storage for various mooring components. LOSOS North is a support facility for LOSOS. It specifically provides workspace for the global subsurface moorings, as well as the autonomous underwater vehicles in use by CGSN. The 8 flanking and 4 hybrid profiler moorings of the Papa and Irminger arrays are managed by the Subsurface Mooring Workshop. Similar to how the high bay is used for the coastal surface moorings and the global surface moorings, following recovery, the subsurface moorings are returned to the workshop, where they are disassembled and the various components, the mechanical, electrical, and instrument components, are delivered to each responsible laboratory for refurbishment. Once refurbishment is complete, all the components are then reassembled in this specific workshop and enter a burn-in program similar to the surface moorings. Burn-in testing is monitored by the subsurface team to verify functionality of all the subsurface moorings and its components. And once the testing is completed, the moorings are prepared again for shipping or deployment, depending on the port of mobilization. The area outside the workshop also provides a large space for long-term and short-term storage of major mooring components, as well as for staging for deployment, preparations, or shipping. Within CGSN, autonomous underwater vehicle, or AUV, usage is specific to the Pioneer Array. The AUV lab also manages vendor refurbishment activities and any scheduled maintenance. There are 2 vehicles plus spares within the CGSN inventory. These have a planned deployment of every 2 months. They may be deployed from charter vessels or from major mooring turn cruises. The Coastal Research Laboratory is the home of the Mooring Operations and Engineering Group, which provides significant support to CGSN. 2 primary areas that they provide from a facility standpoint are the Polyurethane Laboratory and a secondary high bay. The Polyurethane Laboratory is primarily responsible for the build and development of the terminations of various riser components, such as the electromechanical chains, cables, and hoses in use by the surface and profiler moorings. Originally, these terminations were rebuilt following every deployment. Now, with upgraded termination designs, the Polyurethane lab can refurbish the terminations. increasing reliability and decreasing cost and schedule. The CRL high bay has several uses for CGSN. The maintenance of the anchoring systems, acoustic releases, line packs, and various rigging components of the moorings take place at CRL. CRL also has a large saltwater tank with the capacity to test many of the large CGSN components, such as the multifunction node shown in the middle picture. The CRL high bay is also the home for the WHOI CI remotely operated vehicle, or ROV. Here, the ROV is prepped for Pioneer anchor recoveries or for shipping to the West Coast for use on the Endurance Array for anchor recoveries and mooring inspections. The test tank is also used for regular dunking of the ROV to ensure all systems are operational. Woods Hole Oceanographic Institution has various support facilities that CGSN and WHOI can leverage to manage the arrays. These include a number of test facilities, rigging and fabrication shops, shipping and receiving, and marine operations. WHOI operates a pressure test facility that includes 2 chambers. The first, a large chamber, 25 inches in diameter, 78 inches long, can test up to 20,000 psi. The system can be fully automated for 24/7 unattended operation and can complete 140 10,000 psi cycles per day, or 40 cycles per day at 20,000 psi. The smaller chamber is just over 8.5 inches in diameter and 34 inches long and can test up to 12,000 psi. Both chambers have the capability of providing electrical connections, fiber optic connections, lighting, and video. These chambers can be used to test pressure housings or instrumentation to the operating depths of the WHOI arrays. WHOI also operates various test tanks. The tall tank, a vertical tank, 1.7 meters in diameter and 20 meters tall, can be used to test instrumentation and floating instruments. The tank also has a glass roof, which allows it to easily test systems that operate iridium and GPS. The flume tank, 20 meters long and 1.2 meters wide by 1.2 meters deep, is elevated above grade with one side of glass for full-length visibility of any instrumentation that's being tested. This tank could be used to test current meters or calibrate current meters. WHOI operates a full suite of rigging and fabrication shops. These shops operate modern equipment such as water jetting, precision cutting and welding, and 3D computer milling. For CGSN, these shops support the repair and replacement of all the mechanical components of the moorings. This could include buoy towers, buoy wells, the near-surface instrument frame, as well as the multifunction node. These shops can also perform the milling of housings and pressure housings used to house all the control systems and power systems and data management systems. These shops also perform the fabrication of new and updated designs for the mooring systems, as well as supporting the labs and building test fixtures. Having these shops on the WHOI campus is a significant benefit to CGS. In-house mechanical engineers can submit models and plans directly to the fabrication shops, allowing a quick turnaround on components. WHOI operates a full-time warehousing, shipping, and receiving department. This department is fairly important to CGSN. The shipping and receiving personnel and equipment are used during the mobilization and demobilization of every array managed by CGSN. This includes short movements, moving Pioneer moorings from the LOSOS yard down to the dock for mobilization, or trucking to the West Coast to support the mobilization of the Papa array, or international shipping to a mobilization port such as Reykjavik for the Irminger array. The department will also manage the various documentation types required for shipping, the shipping contracts, the customs and duties, import and export documentation, as well as documentation for hazardous materials. WHOI has a dedicated marine operations and facilities group. They are responsible for managing all of the land-based facilities such as the WHOI dock, as well as managing the vessels operated by WHOI. This includes vessel maintenance and crewing, but in particular includes cruise scheduling. CGSN works closely with marine operations to ensure array turns and cruises occur within the optimal seasonal windows, that the vessel is outfitted appropriately for deployments and recoveries, as well as communicating cruise priorities and mitigating cruise risks. WHOI Marine Operations operate 3 primary research vessels and a series of smaller vessels. The 3 main vessels are the research vessel Atlantis, the research vessel Neil Armstrong, and the research vessel Tioga. For CGSN, the primary vessel in use is the research vessel Neil Armstrong. The vessel is mobilized 3 times per year for CGSN, twice a year for the Pioneer Array, and once a year for the Irminger Array. CGSN may mobilize other vessels at the WHOI facility, such as the RV Tioga or other third-party charter vessels, to support interim cruises such as glider launches and recoveries or AUV surveys. For the Papa Array, CGSN would request a vessel from a West Coast institution, such as the research vessel Sekuliak or the research vessel Sally Ride. In service since 2015, the research vessel Neil Armstrong has proven itself to be a very capable vessel. The vessel is outfitted with a long list of the latest acoustic and oceanographic sampling equipment. The large workdeck area and ample lab space also allow the vessel to be very flexible in accepting additional equipment, such as launch and recovery systems for AUVs and ROVs, and the winches and materials required for the recovery and deployment of all the mooring systems. The vessel is also crewed by highly trained personnel knowledgeable in oceanographic operations. The modern vessel and equipment, the operational flexibility, and the professional crew make for a very safe and effective platform. That wraps up our virtual tour. We hope you found the discussion on the dedicated and support facilities of CGSN informational and interesting. If you have any further questions, please contact Al Pluteman, the CGSN Principal Investigator, or Derek Buffitt, the CGSN Program Manager. Thank you for your time.